So John, if I was a customer just learning about SMC and safety, where would I begin?
Well, you would first of all start with the risk assessment, which means that you take a look at all of the hazards associated with the machine. Ideally, you try to design them out with an inherently safe design. And when you can't, you need to be able to add some kind of controls to remove those hazards or reduce them to an acceptable level.
And who determines what is acceptable or what is an acceptable level of risk?
Well, the owner of the machine or the builder of it generally has to determine what's an acceptable level of risk, and that really has to be a consensus decision. The company would need to determine what's acceptable for them. They have to have a consensus among their management team as to what constitutes acceptable, and that could be different for different companies and for different environments.
Okay. And when you go through the risk assessment, safety functions would probably be something that would be looked at. What are some examples of safety functions that we could solve in the pneumatic world?
Well, the traditional method is to do a full e-stop, which is something like this. We would vent the entire system. We're using a 2-channel valve, which has redundancy built into it, as well as reporting or feedback. The problem with that traditional method, though, is that it can be a lengthy process to recover from that. For example, in this system, I have to reset the alarms for each safety zone, and I have to reinitialize the system, rehome things. I may have to clear parts from their cradles and do other kinds of things. And that can take a few seconds, maybe even as much as a minute. But that's been the traditional method.
So that does take some time to get everything back in order.
Exactly.
What are you seeing today? What are the trends of today's safety?
The newer thinking in safety is to try to localize it to just a particular zone. Rather than venting the entire machine, we may have a localized safety function. And for example, if I'm interacting with this cylinder here that I don't necessarily want to pause the entire machine. I want parts to be able to be fed in and out and the rest of the machine to do what it needs to do. So I can come to a safe stop just at one area. So I've got a safe stop here. I've got a redundant stopping system. I used a brake to stop the cylinder, and I used a pilot-operated check valve. So I had 2 ways of stopping movement. I also vented the pilot signal so that I am preventing an unexpected startup. So this is assuming a relatively high level of risk and a relatively high level of safety that is required, or a performance level, as we say. And so then we also have feedback from each of these valves confirming stop, and we have feedback from the pilot-operated check valve. But the beauty of a system like this is that the rest of the machine has been able to continue operating, and recovery from the C-stop is very painless. It goes right back to work once we've adjusted the problem.
And are these components available today?
Yeah, these components are available. This example here with the zoned manifold, these components are available. And once a safety function has been determined, SMC can assist with selecting suitable components, what we call validated operational components.
Thank you.
Thank you.